Hello, everyone. My name is Weida, who I'm now a postdoc at Texas A&M. I'm glad to have this opportunity to share my recent work about the average ISM property of galaxies probed by UV emission lines. So UV wavelength range in the galaxy spectrum is very important. That provides a lot of galaxy like chemical abundance, ionizations, information, but observing UV emission lines is extremely hard because they are considerably weaker than strong optical lines. So in this work, we take an opportunity to the deep cycle 1 spectrum to stack them and to construct a composite spectrum to study the average galaxy properties. We select the galaxies from cycle 1J and series surveys. We constrain the redshift range from 5.6 to 9 to for the wavelength coverage from carbon 4 to oxygen 3. We normalize the spectrum by their UV luminosity and perform the medium stacking. Here on the left shows the overview of the composite spectrum, on the right shows the zoom in to the emission lines that are significantly detected. As you can see, a lot of lines are well resolved, like carbon 3 to 2 carbon 3 lines, and we also marginally resolve the oxygen to doublet. So these lines allow us to measure the electron density in different ionization zones. We also have detection of oxygen 34363, which allow us to measure the temperature. So, and we can also directly measure the oxygen abundance and the carbon abundance. Based on the measurement, we compared the carbon to oxygen abundance ratio of high redshift galaxies to the previous measurement of lower redshift galaxies, and also a recent measurement from JWST. The dashed line, black dashed line here indicates the average trend of the low redshift galaxies. As you can see, all the high redshift observations are lower than the average trend of this dashed line. So the carbon to oxygen abundance ratio is regulated by two mechanisms. The first is the different timescale, production timescale of carbon and oxygen, and secondly, the different timescale, and secondly is the oxygen preferential outflow from the supernovae of short-lived stars. So this lower carbon to oxygen abundance ratio may indicate the high redshift galaxies have a very rapid assembly of stellar mass within like a timescale of 100 million years, or they have an oxygen preferential outflow. We also, based on this observation of UV lines, studied the ionization diagnostic. There are a lot of diagnostic diagrams in UV range have been proposed here. We show carbon 3 to helium 2, oxygen 3 to helium 2 as an example. The dashed line here shows the line separators between different ionization sources. On the left, we have AGN star formation and shock, and the right shows the AGN star formation and the composite region. As you can see, our composite spectrum tend to be lower and very close to AGN region, indicating they have very high ionization, and their location also similar to those low redshift, very extreme galaxies. Yeah, that's basically all my results. Yeah, thank you.